morning, and thanks, Will, for the introduction. Just a little bit about what we do. The Centre for Agricultural Engineering at USQ has been around for about 25 years, so some who have had some close association with the university will probably recall that we were the National Centre for Engineering and Agriculture, set up some time ago as a joint venture with Queensland Government, but these days operate as a centre within the university. Some other recent developments that may or may not interest you is that we've restructured our Research and Innovation division within the university, and the Centre for Ag Engineering now fits within the Institute for Advanced Engineering and Space Sciences, so which sounds quite amazing. But we've in recent years developed up quite a lot of research expertise around future materials, fibre composites, but also astrophysics, and we've got guys doing work on rockets and with NASA as well. So quite a lot of good work being done out at the university, and obviously connected globally to the sorts of things that are going on at the moment. But today what I want to do is spend a little bit of time talking to you guys about agriculture, which is why you're here, and some of the developments that are going on within the scene. So it's just useful to have a bit of an idea of what's going on, how that might relate to businesses on the ground. So what I wanted to do was I'll go through a series of slides just talking about different aspects of technology. And I guess just to provide some sort of context of what's happening and how that then might play out. As I said, obviously farming is becoming more technology orientated. Certainly sensor technologies are fairly well advanced these days in terms of what you see. And there is a move towards automation. So a lot of what you see now in terms of sensors and analytics do inform a future around automation or autonomous systems on farm. So obviously large amounts of data are being collected on farm, but you want to be able to use that data to make a decision. In the future, there are opportunities to exploit that data through artificial intelligence and big data analytics. But the key here is to be really focused on what is the particular problem you're dealing with. So as either farming businesses or advisors to farming businesses, what are the pressure points that really make the business tick? What are the things that you need to manage more precisely which are going to improve your productivity or your profitability? And that's usually where you should be looking in terms of a piece of technology. So again, in this space there's been a lot of technologies and a lot of hype around ag tech, but to sift your way through that, it's really about identifying what are the sorts of things that you need to make, what are the sort of decisions you need to make on farm that are really going to count, and how does a piece of technology allow you to get there. So that's very important. You can see that obviously there's some space age concepts up there. The Mars project is one that's being developed by AGCO, but we've got more practical sort of applications down the bottom. Case New Holland released their driverless tractor concept a couple of years ago, and in fact that toured down to AgQuip in New South Wales before it then went back to the US. John Deere has also had an autonomous tractor concept which they launched in 2012. And I think both those machines now sit within a museum in the US, so that gives you some indication of how advanced some of these ideas and concepts are. I might add too that in terms of picking up the piece around our work and in agricultural technologies, one of the things that we do is we work with John Deere in the US, so that's obviously an important partnership that we've got. So we do a series of projects with John Deere, and we're currently looking to commercialise tech through them as well. And in fact, I had a teleconference with them this morning. So it is a very functional working relationship. And it just gives you a good indication that you guys have got access or sight of the sort of things that are emerging around the world, as Will said. So if we look at some of the use cases, if you like, around data analytics and what sort of informs this at the moment, in the early days, it was really about harvesting information on machinery for doing some sort of machine diagnostics. So, you've probably seen the YouTube footage where, the farmer in the cab gets a call from the dealer before he knows there's a problem, and then 2 minutes later the light comes on and he needs to replace the air cleaner or something like that. So a lot of the sensing technologies that sit on machinery are about informing how to improve the performance of that machine. But obviously machinery that's collecting lots of information could be integrated with other data sources, and so in the future there's the opportunity to combine that information to make more strategic value out of that sort of data. So less so about the performance of the machine, but more about management practices on farm around agronomics and those sorts of things. A simple case down the bottom here is just a map of a field that has almost like a yield map, but that's a map of fuel use per hectare. So you can see that there's some areas there that are obviously using a lot of fuel, and you could use that map, for example, to do some strategic tillage. So rather than work up, say 1,000 hectares of country twice, you might work it up once, and you might go back and work up the areas that probably used a little bit more fuel previously, which indicated perhaps that that ground needed a second working. So there's ways and practical ways in which you can use that data to exploit it. Some of the advances that are going around at the moment in terms of sensing is around plant reflectance. So this is where you've got sensors that are looking at the reflectance of the plant, and they're able to identify how healthy that plant is. Maybe it's a nitrogen stress. Maybe it's something else that a variable rate applicator can apply a treatment. So traditionally, reflectance type sensors like that are being used to identify weeds within a fallow, so that as you're spraying the farm rather than spray the whole farm, again, you're only spraying a small percentage of that area because you only want to target the weeds. So rather than broadcast the lot, you just target the weeds. There's other technologies that are floating around, electrical conductivity. So again, rather than sample the whole farm in terms of a soil testing, what you can do is strategically sample areas of the farm based on where the soil varies. And so using sensor technology like electrical conductivity, you can identify where those zones are and manage those zones differently. So you might find that some fields in areas of those fields are more productive, and so you want to manage those inputs differently to, say, the lower producing areas. And I was talking to a landholder just recently, even applying this concept to a cattle operation where traditionally he'd fenced off areas that weren't that productive away from cattle, and now what he's doing is looking to go back and put goats in those areas and at least get something out of what he would have previously written off. So those concepts, if you like, apply for both cropping and livestock industries. The bottom diagram there is probably a little bit hard to see from where you are, but that relates to some technology that we've been developing out here and we're currently commercialising. And this takes the sensing technology a step forward, where we're using machine vision to analyse an image and to be able to discriminate certain things on that image against something else. So in this case, what we're doing is discriminating a weed from a crop. But what we're doing there is that weed is very similar to the crop, and so we're able to spot spray, if you like, with a reasonable degree of accuracy, a weed that looks very similar to the crop. And so it's quite difficult. We can do that at 20 kilometres an hour, which is probably faster than most people could run in this room, so, or at least sustain running. Some of the other areas that technologies are being used is around phenotyping. So this is informing how plants grow and the sort of attributes that then lead to productivity. So again, as a farmer or an advisor, you're looking at the crop all the time, you're understanding how that crop looks. There's certain signals which then inform how you might manage that crop. And so a lot of sensing technology is being focused around phenotyping, which is how a plant genetically expresses itself in the field, and then using those signals to manage it. So for example, a classic case is in the middle there, where again we're measuring stem elongation on sugarcane. So sugarcane can grow up to about 1 inch a day when it's well watered, and when it's looking for a drink, probably grows half of that rate. And so if we've got cameras looking at the change of growth rate from that crop, we know when it actually needs a drink. So if you look at the crop, it's very hard to see that the sugarcane's wilting, but just by monitoring the daily stem elongation, which you can do with camera systems, you get an indication that that crop's now looking for a drink before it actually expresses some sort of wilting or drying out. And that obviously then relates to quite a large amount of productivity benefit. Some of the other concepts that are going around in agriculture at the moment is the Internet of Things. And really this is just about connectivity on farm between various sensors and trying to integrate that information to make decisions from that. And to give you some sense of how the landscape is changing in this space, this is not just about putting soil sensors out in the field that are connected through some sort of telemetry. This is actually taking information that sits on a whole heap of different machinery, as well as stationary sensors in the field. And so we've got a fairly recent model John Deere header up here in the right-hand corner, and there's probably about 100 sensors sitting on that machine that's recording information as it's harvesting, and that can give you some insight into not only the performance of the harvester, but some indication of the crop that it's actually harvesting as well. So that information then can be integrated with perhaps data that was collected at planting or other information around the farm to make more informed decisions about how you might go about doing things. So this is about being more connected to the farm using that information to make more accurate decisions, which are obviously going to improve productivity and obviously profitability. The other thing that's really important in this space is decision support tools, and you might have heard of this. So we're sensing a lot of information. What do you do with that information? Well, you want to turn that into a decision or some sort of action. And so obviously if you're collecting lots of information, you can't process that yourself. You need computer models to be able to process that information. And so where the ground has truly changed in the last few years is a move away from biophysical models into more mathematical artificial intelligence. So a biophysical model essentially simulates a physical or a biological process. So you might have heard of crop simulation models like APSIM, which has been developed by the CSIRO. And that's essentially breaking down a biological process and actually simulating how a plant grows in the field. And obviously those sorts of things require a lot of agronomic field trials, a lot of understanding around the crop and how it operates. But these days what we're looking at is transferring away from that sort of technology to just making sense out of sensor data. So rather than try and understand the physical or biological aspects, if you're measuring a lot of things here and you're understanding how that then, and then you're getting some sort of signal at the other end which says this is how the crop's performing, artificial intelligence is really about the mathematics around connecting those sensor inputs to the sorts of things that you're getting at the end point. So it's not trying to understand the process, it's just trying to understand the relationships between your inputs and your outputs, and it just represents that through mathematics, whereas the old way was about understanding the actual physical aspect of what was happening, how the crop was growing, what were the biological things that were going on there behind the scenes. Explaining these concepts because they're often terms that come up in the media, and it's just understanding how these things are informing what's going on farm. One of the great things about artificial intelligence is that you don't necessarily need to know a lot about what you're doing because you can rely on the mathematics. The only problem with that is you need lots and lots of data, and at the end of the day you still need some domain knowledge to interpret what's going on as well. So there's always pros and cons with these sorts of technologies. Autonomy and variable rate technology. Hopefully this is a little bit more, a little bit more mainstream in ag at the moment. I mean, of course, we've had auto steer since the mid-90s, so that's certainly not new. But we've also had auto spray now for probably at least 10 years. So this is where we can, develop prescription maps and spray the field depending on what we've already pre-programmed the controller on the sprayer. But we're now getting a little bit more intense in terms of the detail in which we collect information. And so we're going down from a zonal management of a field down to individual seed or plant management. And that's what's informing the variable rate technology space at the moment. So traditional areas of variable rate technology relate to spraying, but increasingly we're seeing that come into the frame with seeding. So again, more productive areas, you might increase the seeding rate, less productive areas, you reduce the seeding rate. Areas where you would have traditionally had more weeds, perhaps you might increase the seeding rate to get better competition between your crop and your weeds. So there's all sorts of ways in which variable rate technology now is informing different practices on farm. And you can do that in the cab, right? So you don't have to stress about it, it's about using the technology to achieve that sort of outcome. We're also doing some work in irrigation. And again, different parts of the field are going to be more productive than other parts of the field. So why wouldn't you change the amount of irrigation that you apply to those various parts? And what you might find is you get an overall increase in yield across the whole farm, while at the same time you might actually get a reduction in water use. Robotics is coming to the fore as well, and the difference here is really about robotics is about autonomous systems. So systems that know something about what they're doing, something that they can improve on the run and change what's happening. Field robotics is obviously being applied to tractors in particular, but other things like sprayers and pickers and harvesters come into that frame as well. So some examples here of robots where you've got the Swarm Farm technology, which has been developed by Swarm Farm out of Guindy in central Queensland. We've got the Case tractor up there. Another technology down the bottom is Blue River, who developed a spray system, and what they are doing there is in fact identifying lettuces in a field, and they're actually spraying lettuces or trying to weed out or thin down the lettuces to get nice uniformity across the field, and they're using a solution of urea and water. And so what they're doing is they're actually burning the lettuces that they don't want to get good uniformity across the field, but because they're applying nitrogen, they're actually fertilising the ones that they want to keep. So it's a really nice, elegant solution. and of course other sort of more hands-on type robots, which is picking fruits and trying to reduce labour and the sort. So that's the sort of landscape, if you like. They're the sort of technologies that are emerging, and so what I wanted to do is make that connection now between the scene, if you like, in agriculture and ag technologies and some of the things that you might see if you came out and saw me, which I'd love to see you come out sometime. So we have developed some technology, as I said. We're trying to commercialise that at the moment. And this is a field of sugarcane that was going to be ploughed out. The right-hand picture there is the row with the crop and the weed, and it probably wouldn't make any difference if you were standing there or there. You probably still can't tell the difference between the weed and the crop. But we can, and we can do that through machine vision. And what we've been able to do there is spray out the weeds, and you can see that through that white area in the field using Roundup, and essentially recover that crop which would have been ploughed out. So that's a great application, a great practical application of the technology. The smart irrigation work that we're doing, so this is about irrigation systems that can see, think, do, reflect on what they've done, and then actually change or modify what they've done previously. So again, we've developed sensor systems that can see the crop and interpret how the crop's performing, integrate that information with climate data or perhaps soil moisture data, understand how much water you've got available for the season, and then work out an irrigation schedule and apply it. And when it's done it sees what it did last time, it sees how the crop's responded, and it then iterates again and comes up with a new schedule. So these sorts of technologies easily lend themselves to things like centre pivots and lateral moves, which are large mobile irrigation systems in the field, but they also lend themselves to traditional surface irrigation systems that we see in cotton. Okay, so some examples on that slide of sensors that we've got in the crop, either sitting on a centre pivot or measuring flow rate on siphons, running an irrigation event, and then adjusting that on the run. And what we see is that we can again improve our performance by at least 10% in yield, 10% reduction in water. Surface irrigation systems, particularly used in the cotton industry, improved irrigation efficiency from 60%, well up to 90%. So getting performance out of furrow irrigation systems similar to, say, drip or even lateral move irrigation systems. Similar UAV scouting, this is where you're just using the technology to do some reconnaissance across the field, automatically identify where the weeds are, and put that map into a spray controller on a tractor. And so rather than kit out the boom with $200,000 worth of sensors, you can send up a drone, it'll work out where the weeds are, and you can upload that prescription map into the spray tractor you've got. So a large amount of our work is trying to mobilise the technology that already sits in the field, i.e. technology you've already bought, or technology that's already on the shelf, so that we address that path to market, so that we can turn this research output into a commercial outcome pretty quickly. Again, working with the machinery that you've got now, while some of that looks pretty funky, a lot of the technology or the platforms, particularly around the green and the red, sit on the machines that you've already purchased. And just to clarify that, if we actually look at the sort of features that sit on a tractor now, those features inform fully autonomy, and so what we've been able to do is qualify amongst the major tractor manufacturers which tractor manufacturers are the most advanced in terms of their product offerings that could easily lead to automation. Again, we're working with John Deere in this space at the moment to try and accelerate access to autonomous tractor technology. Okay, so again, these manufacturers have a pathway to autonomy where they look at it and say, okay, well there's a challenge, there's a risk, perhaps a liability in having a fully autonomous system where you've got no one in the cab. But if we look at what are the pieces that we need to develop along the way to get us to that point, we can release that as products and as features on the current machinery that adds value to you as a customer, but obviously adds value to them as a manufacturer. And so that's their philosophy. And what we're trying to do now is mobilise that into the next step, which is to automate that on farm. So, obviously these things have got to have an impact. They've got to, produce a profit, or it's not worth investing in those sorts of things. So let's just have a look at some numbers. If we look at precision agriculture, normally you'd expect a $22 per hectare improvement, and I'd say that's pretty conservative. Numbers that I've seen suggest as many as $80 or $90 per hectare, and so the new technology is about trying to enable those opportunities. We do see, and perhaps you guys see in terms of the clients that you might have, is large differences between the top 20% of growers and the average. And so it begs the question, how do you bridge that gap between your top producers and your average producers, and what is that difference? And so we know in the grains industry that the difference is as much as $150 a hectare. In livestock it might be $340 a hectare, and in cotton it might be as much as $1,000 a hectare. So the top 20% of producers in cotton are earning $1,000 per hectare more than the average. And so, that's the challenge, that's the opportunity. In terms of other things and other benefits, some rules of thumb, 2% yield loss per day for delays in planting. So if you've delayed planting for a week, then you've lost quite a lot of yield potential. So again, technologies that allow you to get in the field at the right time are really important. I've mentioned the irrigation savings earlier. Certainly crop losses, anecdotally, 15% crop losses through not getting in and treating at the right time. In some, particularly in North America, 10% seed and fertiliser savings through section control. So this is not overplanting areas or underplanting areas, and then controlling the amount of seed that's supplied on headlands and so forth. And then finally, things like weed seeker, which is 80% savings in herbicide. So, think about it. Every time you go to spray a field, if you don't have this technology, 80% of it is just simply going to waste. And so that's where this technology is really important. Obviously, machine optimisation is a key component of that. And as I said, what we're trying to do is that little tractor down the bottom there. That's one we purchased last year, and we're looking to automate that at the moment. And some numbers suggest that we could replace, say, a 400 horsepower tractor with 3 60 horsepower tractors. Obviously, the capital cost is much lower of the smaller tractor. And there's obviously other benefits and savings there as well. Some things that you might see also is that across the farming operation there's a base level of labour throughout the 12 months, but at certain times of the year you've got peak load. It might be with planting or harvesting, and so autonomy is about trying to reduce where that peak in labour is so that you can maintain a steady workforce. So this is not necessarily replacing labour, but it's about trying to overcome those areas where you can't source labour. And I just wanted to wrap this up by just looking at the future. So obviously there's a lot of technologies out there. The research that we're doing out here at USQ, and particularly in Australia, I'd like to sort of extend that. It's not just at USQ, but certainly this ag technology scene in Australia is quite advanced and at the forefront of ag tech globally. We can certainly say that we're on that leading edge, and we've got partnerships which prove that. As I said, we've got a great relationship with John Deere at the moment. We're doing work with Climate Corp and Monsanto in the US. And what we're trying to do is accelerate the access of that technology into the Australian marketplace. There's a lot of technologies out there, obviously, and there's no silver bullet solution. So, it's a bit like a shopping cart. You've got to pick the one that's suitable for you. And I guess the main thing is that you do focus on what the problem is and address that through the selection of technologies that you want. The other point I just make there around data at the moment, and particularly in agriculture where there's a lot of hype around big data, getting some sort of insight into data means you've got to have good data in the first place. And so one of the things in ag at the moment is, whilst we think we've got a lot of data, we don't nearly have enough for the sort of analytical techniques, although we will in the future as these technologies come on board. But you can't make any decisions, or you can't get any insight out of that data unless you've got good data to begin with. So, I suspect that a lot of the that adage there is probably similar to every other business here in the room in terms of how you're trying to manage what's going on. And as I said, this is universal. Ask the right questions. What are we trying to do? How's the technology inform that? Thanks, Will.